Hello students, today in your video we are going to look at properties of mathematics, specifically the distributive property. So the title is going to be this, and I'm going to ask you to go to the first blank page in your composition book, and this is where we're going to write those notes, and it's going to be 1A-1 Distributive Property is the title. And kind of the rule of thumb when taking notes from the video is, because sometimes you'll have a notes page but sometimes you won't, but the rule of thumb is whatever's written here goes on your composition book. So whatever I write down, you should write down also. Okay, so we're going to look at the distributive property. The distributive property is a property in mathematics that's a multiplication property, and it looks something like this. And you could have A times the quantity of B plus C. Now you know that the parentheses acts as a multiplication sign. So we're multiplying A times everything inside the parentheses. Well, you know from order of operations that I have to do what's in parentheses first. Well, I can't add B and C together because they're not the same. So I have to multiply the A times everything inside the parentheses. So I'm going to take this A and I'm going to multiply it by the B. And when I multiply A times B, I get AB. Okay? Because they're not the same, I can't do anything else. They're not numbers, it's just A times B. And then I'm going to take that A and I'm going to multiply it by the positive C. So A times C is AC, and I have to put a plus sign here because it's positive times a positive. That makes positive. So the distributive property, I take whatever's on the outside and multiply it by everything that's on the inside. It only works if there's a plus or a minus inside the parentheses. Okay? Now let's look at one that has real numbers and letters in it. So we're going to take the problem 3 times the quantity of A minus 2. Okay? 3 times the quantity of A minus 2. And when I say times the quantity of, that means something's in parentheses. Times the quantity of always means it's going to be in parentheses. Okay? So I'm going to take the 3 and multiply it by both terms that are inside the parentheses. So I take 3 times A and I get 3A. And then I take 3 times negative 2. That minus sign also acts as a negative for that 2. So 3 times negative 2, you know, is negative 6. So 3 times the quantity of A minus 2 is 3A minus 6. Now here's where most of the problems happen when we're doing distributive property. You multiply the 3 times the A and then you forget. And then you just write down minus 2. Doesn't work that way. You got to multiply the 3 times everything inside the parentheses. Sometimes I can have more than 2 things. So what if I have this one? You write this down. Let's do 4 times the quantity of 3A minus 4B plus 7. Okay? So again, I have 4 times a big quantity. There's minuses and pluses, so I'm going to have to multiply that 4 times everything that's inside the parentheses. So 4 times the 3A would be 4 times 2 is 12, so that's going to be 12A. And then 4 times negative 4B would be negative 16B. And 4 times 7, and it's a positive 7, is going to be positive 28. So that's the use of the distributive property. We're going to extend it in just a second. So we're going to go a little bit deeper with the distributive property. And what if I have an expression that includes the distributive property, but it also includes other stuff? Well, I have to do the distributive property first because that's the order of operations. Multiplication comes before subtraction. So I've got to just leave the 15 just like it is. So I'm going to bring it down. I'm not doing anything with the 15 yet. Okay? But I am going to distribute the negative 3 to everything inside the parentheses. So I've got negative 3 times A is negative 3A, and negative 3 times 7 is negative 21. So now I have 15 minus 3A minus 21. And I can combine like terms. Like terms are anything that have exactly the same variable. 15 and negative 21 don't have a variable, so I'm going to do 15 minus 21, and that's negative 6. The negative 3a, there's no other like variables. There's nothing else I can add to a negative 3a. There's no more a's anywhere, so I'm just going to go negative 3a. So the final simplification, that's what we did. We didn't solve anything, we just simplified, is negative 6 minus 3a. I could also write that as negative 3a minus 6. It doesn't matter what order it's in. It's completely up to you. Typically, we put the variable first, but it doesn't matter. The last example we want to look at in dealing with the distributive property has 3 times the quantity of 3x minus 1 minus the quantity of 4x plus 11. Okay? Let's just do this first part real quick, and then I'm going to explain why this one is so problematic. The first part, I'm just multiplying 3 times everything inside the parentheses. So first I do 3 times 3x, which is 9x. And then I do 3 times negative 1, which is exactly negative 3. Now here's where it gets tricky. Okay? I have minus everything inside the parentheses. So there's 2 ways to look at that. One way to look at that is take that minus and put a 1 right here. So I actually have a negative 1 in front of this parentheses. Okay? Because there's not a number there, I know it's understood to be a 1. So this would be negative 1 times everything inside the parentheses. Or you can just say minus 4x minus 11. That's the same thing. But when you have a minus sign in front of a set of parentheses, the minus sign has to be applied to everything inside the parentheses. So minus times 4x is negative 4x, or negative 1 times 11 is negative 11. That is where 99.8357% of all mistakes happen with the distributive property is with a minus sign in front of a parentheses. You forget to put that 1. Remind me one day to tell you about why we don't put a 1 there. It's a very, very good story about blueberries. So let's move on. I've got 9x minus 3 minus 4x minus 11. So I'm going to combine like terms. 9x and negative 4x. So 9x minus 4x is 5x. And then I have negative 3 minus 11, which is negative 14. So simplified, we get 5x minus 14. The next part of this video is about combining like terms. So what I need you to do is draw a big squiggly line all the way across your notes so that we separate the 2 sections. So we've got whatever we just did up here, which was distributive property, big squiggly line, and then we're going to put combine like terms. Okay, I know that's kind of a glare on the video, but combine like terms. Okay, combine like terms is doing just that. So let's say, for instance, I have 3x squared plus 2x minus 4 minus 2x squared plus 7 minus 3x. That's a big, long thing, okay? But I need to combine like terms. So I've got to look for everything that has exactly the same variable. And if that variable has an exponent, then it has to have exactly the same variable and exponent. Remember that a variable is a letter, and the exponent is the power that letter is raised to, or that number is raised to, whatever. Okay? So I have a 3x squared. Are there any other like terms? Why, yes, I've got a 2x squared. But this 3x squared is combined with a negative 2x squared. So 3x squared minus 2x squared. 3 minus 2 is 1, so it's just 1x squared. But you don't have to put that 1. All you could have to put is the x squared. I put it for now just because. Okay? And then I've got a positive 2x and a negative 3x. Well, 2x minus 3x, we know that 2 minus 3 is negative 1, so that's going to be negative 1x, or you could just put negative x. And then I've got my negative 4 and a positive 7. So negative 4 plus 7 is positive 3, because negative 4 plus 7 is 3. Now, I could rewrite this as x squared minus x plus 3. Remind me one day to tell you why we don't put the 1 in front of the variable. It's a very, very good story about blueberries. Similar to why we don't put a 1 in front of parentheses if there's not one. Good story. So let's do another example. What if I have 4y squared minus 3x plus 7y minus 3x minus 7y plus 5y squared? I know I wrote that fast in talk, so I'm going to give you a second to write it down. If you need to pause, you can. So now I'm going to look for my like terms. I start with 4y squared. Let's just start there. Do I have any other y squareds? Why, yes, I do have a y squared. I have a 4y squared plus a 5y squared, because the sign right in front of it tells me whether it's plus or minus. 4y squared plus 5y squared is 9y squared. And then I have a negative 3x. Do I have any other x's? Why, yes, I have another negative 3x. Negative 3x minus 3x is negative 6x. And do I have any other y's? Why, of course I do. I've got a positive 7y and a negative 7y. And I know that 7y minus 7y is 0, so I don't put anything. I just leave it blank. So simplify that long statement is 9y squared minus 6x. Now sometimes they're going to ask us to evaluate an expression, which means they tell us what each of the variables represents. You know that a variable is just a letter that represents some unknown number. Well, if they tell us what it is, we just plug that in. So if w equals 5, x equals 3, and y equals 2, I'm going to see what I have. I've got an x here that I'm going to square, so I'm going to replace the x, or substitute 3 for the x. So I have 3 times 3 squared minus 5 times whatever w is, which is 5. Okay? Notice that I've got an exponent here. And remember, order of operations says I have to do parentheses and then exponents. Well, I don't have anything inside parentheses. This is just acting as a multiplication sign. So I've got 3 times 3 squared. Well, what is 3 squared? 9. Minus, what's 5 times 5? 25. Okay? The reason I could multiply right here is because I got that minus there. Right? And now, 3 times 9 is 27 minus 25. And it's 2. So 3x squared minus 5w equals 2 when x equals 3 and w equals 5. So again, I have to combine like terms when I can, substitute when I need to, and then simplify using the order of operations. GEMDOS or PEMDOS, whichever way you learned it, grouping symbols, exponents, multiplication and division, and then addition and subtraction. You have now come to the end of this video. Congratulations!